Ian Stewart, a British mathematician, published a book titled Nature's Numbers.
This book gives an overview of how mathematics is used in the study of nature.
I am Fabi Vanessa G. Bulisa.
I am Hershane Flores.
I am Janelle C. Helomina.
And I am Hilmar Angelamoy, and in this video, we will talk about the fourth chapter, which is the constants of change.
Even in our daily lives, we all experience change, whether it be a simple shift in the temperature, a change in our schedule, or a forecasted shift in the weather.
Change is inevitable, thus, it is occurring constantly. This proves that numbers are not static, but rather dynamic.
Heraclitus, a Greek philosopher, said, "Change is the only constant thing in the world." In the real world, everything is subject to change, like a river where water is not stagnant but flows freely.
In this chapter, two opposing viewpoints on nature are discussed.
The first holds that laws are permanent and that everything in the universe has a well-defined existence, while the second holds that nothing is constant and everything is subject to change. Moreover, it not only asserts that laws in nature and changes can coexist, but law generates flux.
Isaac Newton, an English physicist and mathematician, shared his fundamental insights that changes in nature depict mathematical processes that follows a certain law. Before his discovery, there is Ptolemy's theory of planetary motion, which served as a static model of nature.
Nature is said to be a model of perfection and thought to be unblemished by change. However, Newton disregarded this idea and replaced the forms with the laws that produced them. Newton's fundamental law was being highlighted that force is equal to mass times acceleration, when a detailed consideration of what happens to a cannonball fired out of a cannon was explained by Stewart.
Moreover, Newton, together with Leibniz, who invented the calculus, had the concept of differentiation and integration, which handles the patterns in the rate of change.
A technique for finding the rate of change is known as differentiation. Integration, on the other hand, is the technique for undoing the effect of differentiation to isolate the initial variables.
Mathematics, engineering, cosmology, and many other branches of research all depend on the ability to calculate rates of change.
The relationship between nature's laws and behavior doesn't need to be direct and evident, but it is wrong to see this change as a retreat that there is no formula like a three-body problem.
Nonetheless, Einstein gives an understanding that problems do not simply depend on mathematical processes. Hence, he uses qualitative theory to grasp nature's patterns.
With the information obtained from this chapter, we can infer that
Constants
Constants
generate
generate
change.
change.